For question 10, I'm actually going to do it a little bit out of order. And then you could do it in whatever order you want. But for me, I actually find it helpful to start on part C first, and then and D, and then I'm going to go back and do A and B. All right, so we have gas stations in the U.S. typically dispense gas at a rate of 10 gallons per minute. And in C, we're asked, is that 10 gallons a minute an absolute change or a relative change? And it's an absolute change. And I know it's an absolute change because each minute that goes by, your car gets 10 more gallons of gas. That's an adding relationship. It's going up the same amount each minute that goes by. So it's an absolute change because every minute that goes by, you would add 10 gallons of gas to your car. And that's what makes it an absolute change, having that additive relationship. All right, so assuming that the rate at which gas is being pumped is fixed at that amount, and moreover, we're going to assume that our car is starting with 5 gallons of gas, we want to write a linear function. So I'm going to make G the amount of gas in my car, and I'm starting with 5 gallons, so there's my initial amount, and I'm going to be adding 10 gallons for each minute that goes by. So this is the minutes spent pumping gas, and this is total gas in car. And so the reason I'm doing that is if I now go back to A is saying you arrived at a gas station, you have 5 gallons of gas in your car, you pump for 30 seconds and stop. How much gas is in your tank when you stopped pumping? So we can now use that linear function we wrote down on D to answer question A. Now, the key here is that it is given in seconds, but 30 seconds is equal to a half a minute. So I'm going to plug in 1/2 for M because we have half a minute, and then evaluate. So half of 10 is 5. 5 plus 5 means I would have 10 gallons of gas in the car. All right, now we have a Corolla. It holds 13.5 gallons. How many seconds would it take to fill up your car with gas if there were 5 gallons in the tank before you started filling up? All right, so using our same linear function, I have 13.5 gallons in my car. Started with 5, 10, and this is in minutes. We'll have to do a little bit of converting at the end, but I'm okay with that. So if I subtract 5, I get 8.5 equals 10M. Divide by 10. And so it's going to take 0.85 minutes, but I wanted seconds. So if I there are 60 seconds in each minute. So if I times that decimal by 60, I would find out that it will take me, seconds in each minute. Yeah, I said that. It will take 51 seconds to fill up my car. For some reason, it always feels a lot longer when I'm pumping gas, but the data doesn't lie. Okay, moving on to question 11. We are leasing a car, and there's a down payment of $800, and with the down payment and processing fee, and then it's going to be $240 per month. Stay tuned for our finance unit to figure out how to figure that number out. We're going to write a linear function because you're adding that $240 every month to sort of how much you've paid. So I'm going to call it though C. So this is sort of like the cost I've paid for my car so far. I start with $800. I add $240 each month. And so like this is the months we've owned car. And this is, total paid after M months. We don't know what M is yet. So how many months would you end up leasing this car for if it ended up costing you $3,680? So we're going to plug that in for the C value and solve for the number of months. So I'd subtract 800 and get 2,880. Divide by 240, and I found out that I could lease the car for 12 months. All right, one last problem. And that one deals with a table of values and sort of goes back to some of the stuff we did last week with absolute change and relative change, and then tying that into what we did this week. Oh, it's all connected. It's such a beautiful thing. All right, so we want the absolute change. So absolute change is a new value minus an old value between the weight, the infant weight, for between the ages at 25 and a half months, and 5.5 months. So that would be 12.9 minus 7.6, which comes out to an absolute change of 5.3 kilograms. Now, if I want to turn that into sort of my rate of change, I would take that absolute change and divide it by the change in time. So 5.3 divided by my change in time, well, that's 25.5 minus 5.5, which is actually 20 months. And so that's about, the baby gained approximately 0.265 kilograms per month. Now we want to do the same, but we want to find a relative change. So if we remember, our relative change is going to be the new minus old, our absolute change, but then divided by, not new, divided by our old change, and then turned into a percent. And so in this case, we have that 5.3 we've already found, and then we're going to divide it by 7.3, which is the original weight, or not 7.3, just thinking 0.3, 7.6, and I would end up with 6.697, which would be a 69.7%, and don't forget, increase in weight. Now, that's different if I want a monthly increase. So in that case, we actually sort of want the growth factor. So we don't want the percent change. This was like our percent change. We want sort of the total percent more. So we end up taking that newer value. So new divided by old. So the 12.9 divided by the 7.6. And then we want to undo multiplying 20 times for the 20 months. So we're going to raise that, to the a fractional power. So in this case, 1/20th. And that comes out to 1.0268. Now this would be, remember, in our exponential function, the 1 plus r value. We want just r. So in this case, we would subtract out the 1, and we can see that it grew 2.68% each month. Increase per month. Now, the last question is a little bit of a trick question because it says, which is a better model for the data, linear or an exponential function? And I could argue neither. I would say exponential is better, but probably not the exponential we tend to write because we've been writing exponential sort of growth or decay, and this isn't really either of those situations. It is growing. It's not growing by a consistent amount because if we notice, in the first 5 months, the baby grew over 3 kilograms, and then it's less than 2 and even less, sort of closer to 2, a little more than 2, a little less than 2, like around 1, less than 1. So it's increasing by less each month. And so that rate between each month is not the same when it comes adding wise. We could check it to see if it's the same multiplication wise. So I'd say exponential is better, but neither are really perfect. So that's what I said. It's a little bit of a trick question. So my response is exponential, sort of. And that's the end of this worksheet. So go back, see how you did, fix mistakes that you made, try and learn from them, help our brain grow. And we're going to pick this back up in class this coming week.